All right, and welcome back. So today we are going to be talking about how to add and subtract radicals. Previously, we talked about adding and subtracting polynomials. Radicals are going to be very similar. We just have to take some of the previous ideas and topics that we've talked about radicals, apply it to adding and subtracting them. But it's going to be very similar to polynomials. We're going to be combining some like terms, but we're going to be focusing on the radicals. So without further ado, let's begin. You can add and subtract radical expressions just like you add and subtract expressions that have variables. For example, on the left-hand side, we have 4x plus 2x, and that's equal to 6x. We know that we can add these together because these are like terms, so we can add them. We have been working with terms that have variables for a long time now, and we're showing great strength with that. 4x plus 2x, you would all say, oh, it's 6x. We got it. We're going to have a lot of success. 6x. No, okay. On the right-hand side, we have 2x plus 4y. These are not like terms. They don't have the same variable, so we cannot combine them. Well, working with radicals is going to be fairly similar. We can combine radicals only if they are like radicals. On the left-hand side, we have 4 root 7 plus 2 root 7. Well, that's equal to 6 root 7. These are like radicals. They have the same radical. We can treat them similarly to a variable. Is not a variable because we know the value, but we can treat them as if they are a variable. But on the right-hand side, we have 2 root 5 plus 4 root 3. Those are not like radicals, so you cannot add them. Root 5 is not the same as root 3. So we cannot combine those radicals together. Again, we can treat them similarly to variables, knowing that they're not variables, but combining like terms, it's going to be very similar when we're talking about radicals. Let's go through a couple of examples. Let's say we want to add 8 root 10 plus 5 root 10. Well, these are like radicals. So 8 plus 5 is 13, and we tag along that root 10. What about if we had 4 root 2 plus 8 root 3? Well, one of the first things I notice here is we have a square root of 2 and the square root of 3 in each individual term. These are not like radicals, so we can't add them. So we would just leave it as 4 root 2 plus 8 root 3. Awesome. With this in mind, please work on problems 1 through 10 on the guided notes and resume when you're ready to move forward. All right, if you're listening to my voice, that means you worked on the front side of your guided notes and you're ready to go on to the back side. So sometimes it is necessary to simplify expressions before adding or subtracting. In the previous examples, we had the same radicals and we were able to add them together. And we saw that we had different radicals and we were not able to add them together. But sometimes we can simplify before we add or subtract. So let's simplify the square root of 50 plus the square root of 18. Well, we know that 50 and 18, we can simplify those radicals. You can use whichever method you want to. We're going to go through the elongated way, the drawn out method. But if you can simplify the square root of 50 and the square root of 18, that is all that matters. We're going to go through a very detailed step-by-step process here, but if you want to use the tree method or the grouping method where you start to factor and then look for pairs, that's totally fine. But if you do know your perfect squares, this method that we're going to go through is going to be helpful. So we can factor using the perfect squares. Square root of 50 turns into square root of 25 times 2. The square root of 18 turns into square root of 9 times 2. 25 and 9 are those square roots. We can use the product property. We can break apart each individual radical into 2 radicals getting multiplied together. So now we have the square root of 25 times the square root of 2 plus the square root of 9 times the square root of 2. And we know the square root of 25 is 5, and we tag along root 2. We know the square root of 9 is 3, and we tag along root 2. And now you're going to notice that we have the same radicals. They're both terms have root 2. We have 5 root 2's and 3 root 2's, meaning that we can add them together and we get 8 of those root 2's. Awesome. What if we have something that looks like this? We have the square root of 45a plus the square root of 80a minus the square root of 20. I can automatically tell that we're not going to end up with one term if we're able to simplify. That's because two of these terms have a variable underneath the radical, and the third term does not. So even when we get down to a fully simplified form, it will not be one term. It will have to be two terms because we have terms that have a variable and terms that do not have a variable. But let's go through the same process as we did previously. Again, you're going to simplify these radicals whichever method you want to. But again, if we know our perfect squares and we have a better understanding of that process, it might be helpful for us. So we're going to factor using perfect squares. Square root of 45a turns into square root of 9 times 5a. The square root of 80a turns into 16 times 5a. And the square root of 20 turns into square root of 4 times 5. Again, we can use a product property and break apart those longer radicals with multiplication inside into individual square roots with multiplication separating. And we can simplify, and we get 3 times the square root of 5a plus 4 square root of 5a minus 2 root 5. So we can combine some like terms here. We can combine like radicals. We look for anything that has the same radical. And I'm going to highlight it for us just in case we don't see it. We have root 5a and root 5a, which means that we can combine them together. 3 plus 4 is 7. 3 plus 4 is 7. Root 5a. Now notice, how many terms do we have? We have 2 terms, and that's because one term has a variable and the other does not. Awesome. Fantastic job with this, kiddos. Please work on problems 11 through 19 on the guide and notes. Please let me know if you have any questions. Keep up the great work, and I'll talk to y'all soon.